Good evening, YouTube. It's been a while, and yes, never mind the beard. Let's talk about the smart fraction theory and our new study that we published, well, I guess some months ago, but since I forgot to do a video, it's YouTube new. So let's jump into it. Louis Terman is famous for doing the first longitudinal study of very bright children in the early 2000s or the 1900s, I guess. He has this point that he puts here in 1916 that the future welfare of the country hinges in no small degree upon the right education of these superior children, those in his study. So these are the 135 plus IQ, or roughly the top 1%. Whether civilization moves up or on and up depends on the advances made by creative thinkers and leaders in science, blah, blah. And moderate ability can follow or imitate, but genius must show the way. And so essentially he's asserting that the trajectory of civilization depends on the right tail of intelligence. So if you waste these people's time or suppress them, then basically your civilization will go downhill. Then we have here half a century or so later, Jensen essentially echoing these thoughts. The quality of a society's culture is highly determined by a very small fraction of its population that is most exceptionally endowed. The growth of civilization, development of written language and of mathematics, blah, 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 scientific discoveries, blah, 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 and all these other things are attributed to a rare small proportion of the human population throughout history who undoubtedly possessed, in addition to other important qualities of talent, energy, imagination, a high level of essential mental ability as measured by test of intelligence. He's saying more or less the same thing. But basically no one really studied this aside from Terman until this guy, La Griffe du Lion, who may or may not be Bob Gordon. I've asked Bob Gordon in person when he was drunk, and he said no, and apparently everybody else has tried this, and he always says no, so he may or may not be that person. Who knows? Whatever the case, for those who are old, like me, hence the beard, you might remember in the early days of blogging, in HBD blogging as a matter of fact, there was this blog, well, I mean, it's still there, but it's not updated anymore, where he published this article in 2002, The Smart Fraction Theory of IQ and the Wealth of Nations. That is, as far as I know, the first cross-national study that looked at a sort of operationalization of the smart fraction. After this blog post, essentially the idea was popular, but no one did formal research on it until 2009, where Heiner Rindemann and James Thompson decided to take it into the academics, to the academia, and they had this paper, The Impact of Smart Fractions, blah, blah, blah. And what they come up with is that they use the student assessments tests, TIMSS, the PISA, PEARLS, and some other of these. With these, you can get the centiles of ability by each country, and you can use that in a regression model. And so they show that in their study that the 95th centile, which is the one that reports typically has, there's no particular reason why it's chosen except that it's in the reports, they predict slightly better than the average ability. And that is despite that the higher centiles have a larger standard error and thus are less reliable and thus should have less predictive validity, but it still has slightly higher. In the 2002 blog post, he essentially has this graphical model. And so the smart fraction is defined as the proportion of a population that is above some random threshold. And I think he picked 115 or something like that. And so it's just kind of a one of the normal curve functions, density functions. And that's not really what they are doing. They're looking at the average ability of the 95th centile. Whereas this function is essentially just a nonlinear transformation of the average ability in the cumulative normal distribution function. This other approach is not, and the way you get the data for that one is that here you take a typical PISA study. I can't recall which one this one is, but here you can see that if you look into some PISA score, here we have math performance. They give you the various centiles, the median, the mean, the standard deviation, blah, blah, blah. So you can get these values up here, 641 for Australia, and you can compare that with some other countries, let's say Colombia, 531. And so essentially you take this variable and you take this variable and you kind of compare how good they are at predicting things. There is just this one problem, is that if you try to do this in regression to see which one is more important, or the incremental validity of one of them, you have the problem that the correlations between the average ability, the mean ability here, and these two, the 95th and the 5th ability, they are 9.8. And anyone knows that if your sample size is 100 or so, and you have variables that correlate 0.98, your standard errors will be massively large and your regression model will be useless. So the model cannot really show which one is more important because the standard error is too large. And similarly, the 95th and the 5th ability, they correlate 0.92, which is, better, but still too large for a sample size of 100. So here's what really happens if you do it anyway. Suppose you want to predict something, in this case probably Human Development Index. Apparently I forgot to label the table. If you put them in the same regression model, you see that the mean ability, which is this one, SAS IQ, the C means corrected, the mean ability has a negative beta, which is more or less impossible, and the p-value is also more than 0.05, and you can see the standard error is really large, 0.3. That's not very useful, and if you do the full model over here, you can see it's negative something. Clearly, this model is overfit, and it can't really work here because the variable importance is inflated. You cannot do this kind of model. So we came up with a different idea of using both in the same model. The idea is that you residualize the tails. So what it really means is that if you take the tail abilities, which is to say you take this column and you statistically remove the effect of the mean from it, then this column you get afterwards is a kind of residual that tells you how well the 95th centile people are doing in regards to how well you expect them to do from the mean ability. And the same way with the 5th one. And that way, of course, they will be correlated 0, as it is residual by definition is correlated 0. Nevertheless, it's still informative because if you look at this map, you can see that South Africa is a massive outlier, and that's exactly what we expect. Because we know that South Africa has a white minority that has an IQ close to 100, but maybe 95 or so. And this minor population, or minor proportion of the population, produces pretty much everything worth caring about in South Africa. And so we'd expect it to have a very high smart fraction score in this sense, because the small minority of white children among the sub-Saharan Africans does a lot better than you'd expect from the average ability of South Africa, which is 75 or something like this. It cannot be seen here, but Israel also has a big score because they have a bunch of elite Ashkenazi Jews and then a bunch of Mizrahi Jews and Sephardi Jews and some Arabs that pull down the average. And so the average of Israel is not impressive, but the tail is in fact doing very well. And Israel indeed has a big R&D industry. I don't know why it is Vietnam is so low. Maybe some weird communist stuff, maybe some elite migration that happened after the Vietnam War, even though that's a long time ago. Nevertheless, that's what the data looks like. If you want to look into these data and use them yourself, we have of course published them, so you can click the paper and browse away. Here I put some of them. You could pause the video and look at them. Here's what we're really concerned with in this study. We want to explain worldwide variation in how well your country is. And we've defined how well your country is by the first factor of the social progress index. And if you're wondering what the social progress index is, it's this thing where they have 50 or so indicators that measures pretty much everything you can think of except economics. Why not economics? Well, it's made by sociologists who hate economics. That's why they don't have GDP per capita or something like that. So we want to explain that variation, and here you have a map of these index scores, and it looks like every other world map that you've ever seen about Human Development Index or anything else for that matter. Basically, Northwest Europe is good. Northwest Europe's former colonies are good. Japan, South Korea are good. Everything else is between meh and shit. Really, if you want a model, the main model in our study is this one, where we have the four models here. The first one, we just take the mean IQ, which is actually from these scholastic tests, so PISA and so on. And if you predict this Human Development Index-like factor, the developmentness of a country, you get the correlation of 0.77 or a beta, standardized beta. Then if you add the 95th centile residual, which is our measure of the smart fraction, you can see that this adds some validity. This one doesn't change, and of course it doesn't change much because these are not correlated. We can see that this residual has a beta of 0.3 or so, and it's highly significant. And if you compare the R squared values, you can see that it adds some 7% explained variance, which is non-trivial. And this doesn't work the same way with the 5th centile. So here we have the bottom society, and as you know, most of our policies are based on lifting these people's school behavior. That's why we have all this remedial education and the affirmative action and the enriched kindergarten stuff, blah, blah, blah. It's essentially trying to make these people not suck so much in society. However, we can see that their scores basically don't predict how well a country is running once you control for the mean. And if you put all three in one model, you can see that these first two continue to predict stuff, and this last one still doesn't do anything. In fact, you can also compare these values. You can see that essentially the only model improvement is from adding the 95th, and this other one doesn't do anything. A different way of doing this is that instead of looking at the general score of all of these, you could look at all of them one at a time. And in that sense, you would get 51 or whatever, 50 something regression models, and then you could take an average of that. And here we show the averages. So if you take mean ability only, the R squared to predict the outcome is 70 or 27%, which is not too bad, but less impressive than the 57 here. And that's simply because each of these indicators has a weaker, well, on average, has a weaker relationship to IQ, and it's more noise, and it measures some weird specialized factor about this country, whether this country has decided to put their talents into oil industry or mining operations or enhancing political rights or reducing corruption or whatever. Nevertheless, 27% of each of these on average can be explained, and this increases by about 4% if you add the residual. The second model includes the 95th residual down here. Now we get the same kind of pattern as before. If we add the 5th residual instead, it's model 3 here, we can see that this does improve the model a little bit, but not that much. It adds about 1.5% compared to 3%. And in the final model, you can see that we compare essentially this model, but we add the 5th%, so the lowest ability people, and this increases the R squared by almost nothing. So essentially you get the same result whether you look at this at the average of these scores, this kind of factor score of these, or if you look at each indicator by itself, except of course these patterns are overall a bit weaker, but you get the same rank ordering where the mean is important, and adding the 95th residual shows extra validity, and adding the 5th residual doesn't do so much. It may do slightly above average, but not too much. So you might also think, is this just due to one country like South Africa that causes all these results because it does a lot better than you'd expect? And one way you could look at this is that you could leave out random countries, or rather you could leave out one country at a time, a kind of, leave one case out, cross-validation sort of, except it's not cross-validation. And so here what we get is that this first one up here is the R squared of the model. And so that's the first model comparison. And that's the one that compares the mean ability versus the mean ability plus the 95th. And what you really see here is that in 40% or so of these comparisons, which is to say these 51s, 40% of those we get very strong statistical evidence that adding the 95th is better, and it doesn't really matter much which country we remove. So clearly these results cannot be explained by just one country like South Africa or China or something that causes all the results. These results are not caused by an outlier. We can also do something else. We can say, obviously in our regression models, we didn't really control for anything else. You could say that we should control for geography, or we should control for democracy, or something, your favorite confounder. And one way to kind of explain a lot of these, well, include a lot of confounders in one easy way, is to use what's called the spatial lag. And so the spatial lag is that when you have a map like this, every countries that are similar have something in common. So you could start with, say, one of these countries. I think this one is Chad. You could take the average IQ or the average social developedness of Chad, and you can use that score in your regression model. And essentially what this does is that it controls for anything that is similar between neighbors, and it checks whether your proposed predictors can still predict even when you control for the average outcome level of neighbors. And so, for instance, in this country, we would take the average of Chad's neighboring countries, which will give you some, I don't know, -2 average, and you can see whether these ability predictors can still predict the outcome of Chad even when you have the neighbor's average in the model. And if you do that model for IQ, you get like this. If you take each country's neighbors' countries and you try to predict a country's IQ based on that, the correlation is 0.86. And there are some big outliers like the Philippines and this sort of thing. That these basically have to do with especially these island countries that have no obvious neighbors. And so you might pick some further away country as neighbors, but it just happens to be that Japan is closer. And that's in fact what happens here. The ability predictor of Philippines, I think it's closer to Japan and maybe Korea, but really its IQ is very low in this data set. Remember, these are based on the TIMSS scores and the PISA scores. Nevertheless, this kind of geographical imputation works reasonably well, and so often it would also work as a control variable. So here we have this model. Now we control for the spatial lag, which is the average of the neighbors' levels of developmentness, and we can see that our ability predictors can still predict. And these predictions, these beta values were stronger before, 0.77. Now it's 0.57. So it decreased by 25% or so. Nevertheless, we see the same pattern as before, that the mean ability predicts well. It increases a little bit once we control for the 95th residual. And the 95th residual adds variance. It's about 7% explained variance here. And we get again that the 5th percent doesn't do much. And adding them all together doesn't do a lot more than just having the mean in the 95th. So clearly there's something special about the 95th residual that explains some reasons why countries are doing better than others, even when you control for the average level of developmentness by neighboring countries, which is a good proxy for geography and colonialism and whatever it is you might think of. These factors will be relatively similar for countries that are neighbors. And so really, there's no way out of this conclusion that the 95th residual adds some variance. And that's our study. The cool thing about this study in comparison with the previous ones is that we use this residualization approach, which was much better than the previous approach where Heiner Rinderman and others, they just took correlations and between the mean ability and the 95th ability, and they said, well, the 95th ability correlates, 0.2 or something like that. Not 0.2, 0.02 more with the outcome. Clearly, their findings were not significant, and in fact, they never claimed so. They just kind of had a narrative around it. We did something else. We used residualization, so you could do a proper regression model. We tried many outcomes, so we show that these results are general. It's not just true for this general factor of how well a country is doing. It's also true individually for each of the many indicators. Clearly, the 95th centile ability is important beyond the mean. You cannot really say how important it is in comparison to the mean, because you have removed the mean from the 95th. And when you have them in the regression model with this residual, you can't really compare these betas. You can just show that we can definitely be sure that the 95th residual has some incremental validity. And this is not the case for the bottom 5th centile. And recall again, most of our social policies are trying to boost the bottom 5th centile of people. These are the people who usually become criminals or chronic welfare dependents. These kind of people, it would be better if the thinking in society, if we just need to lift these people kind of out of poverty or cognitive poverty, you might say. But looking between countries, this doesn't look very fruitful. It looks, in fact, much more fruitful to try to boost the ability of the 95th. And now, okay, you can maybe not boost their intelligence. In fact, you probably cannot do that. However, you can definitely improve their actual skill levels by having gift education, which would boost their math ability or programming skills or something like this. And so you can kind of squeeze more juice out of this elite subset of your population. From a political perspective, the conclusions are kind of far-reaching. You might say, for instance, utilitarianism, you should do that thing that has the best overall consequences. And it seems that if the tail ability is very important, this suggests that colonialism might be a good idea, or neo-colonialism, because essentially if you could just move, say, 1 million smart people into an average bad country, then suddenly this country would have a massive right tail effect. The 95th centile would be very much improved, and if these people were then in power, then this country would improve a lot, which is in fact what you find during European colonialism. Europeans have then decided to basically retreat from Africa and these South Asian countries and whatever it is they used to be. And these countries are probably worse off now. The average person there is worse off than they were under European colonialism. On the flip side, you could also say that low IQ immigration is less bad, because though it alters your mean ability in a country, it mainly moves the bottom 5th downwards and the mean slightly downwards. It doesn't really affect the 95th centile. And so immigration is less bad in this smart fraction theory sense. And so maybe it suggests that as long as you keep the right people in power, you could essentially import tons of low-skilled people, and they would have an improved life outcome, as Brian Kaplan likes to talk about. The question then is just that exactly how do you prevent them from infiltrating your politics and making all your politics all this like ethnic conflict stuff that you see everywhere. As you know, the readers will probably know that in America, in the US, black people, they vote about 90% or so for the Democrats, even when their actual political ideology is kind of conservative. They're not very hot on the trans people or the gays or whatever. But they do want more welfare, so to say. Clearly, it's in their interest to vote for more welfare, at least in the short term. So we could say that America used to keep these people essentially disenfranchised and out of politics, but they're increasingly putting them into politics and giving them massive affirmative action in politics. And we have the vice president, who is some useless black woman, sort of black woman. And so it seems that this low IQ immigration, less bad, is maybe not so strongly the case, at least in Western countries, but depending on how it's done exactly, it might be okay. The last thing is that the data we used in the study were compiled by Heiner Rindemann, but probably they're like 10 years old. And so really what needs to be done is that we need to download all the data from these PISA, Pearls, whatever TIMS, redo all the statistics so we can get more up-to-date data. And so hopefully we can get some problems fixed, like the Philippines probably doesn't really have 90 or 70 IQ. It should be more like up here, 80 IQ or so. It's probably due to some bad old data with the Philippines. So it would be nice to update this so it could be done again. And that's basically this study. Thank you for watching.